Quantum mechanics is about the physics of very small things. Specifically, it's about the physics of particles smaller than atoms. And the reason that it's weird is because we don't usually experience the effects of quantum mechanics in our daily lives. If you do experience something weird, you can bet that it was caused by a particle of some sort, either in your body or in the air around you. There are two basic principles of quantum mechanics that you need to know about. The first one is called superposition. When a quantum particle is in a superposition, it exists in many states at once. For example, imagine a quantum particle that has a 50% chance of being in state A and a 50% chance of being in state B. Then the particle is in a superposition of states A and B. Now imagine that this particle is like a little ball that can be in any of these states. When you look away, it will be in one of these states. But when you actually look at it, you will always find it in one of the extreme states. So the act of looking changes the outcome. That's not possible in classical mechanics. In classical mechanics, the ball will be in one of those states whether you look at it or not. But the weird thing about quantum mechanics is that the particle doesn't really go into a definite state until you measure it. Before that, it exists in all of them. The other basic principle of quantum mechanics is entanglement. Entanglement happens when two quantum particles are linked together in some way. If you change one, the other one also changes. Imagine two quantum particles that are linked together such that if one is in state A, then the other must be in state B. These particles could be very far apart, but if you measure one of them and find out that it's in state A, you instantly know that the other one is in state B, even though it hasn't been measured yet. This spooky action at a distance is what Einstein referred to as the weirdest thing about quantum mechanics. Okay, now that you know a little bit about quantum mechanics, let's talk about how to calculate probabilities with it. You might think that if you know the exact state of a quantum system, then you can calculate the probability of finding the particle in a particular place. But that's not true. Even if you know the exact state of a quantum system, all you can ever calculate is the probability of finding the particle in a given range of places. This is because of the uncertainty principle. You can never know exactly where a quantum particle is and also know exactly what its momentum is. So if you know that a particle is localized in a small region of space, you know that its momentum must be very uncertain. In other words, you know that it could be going in any direction. This is why I said that you can only ever calculate the probability of finding a particle in a given range of places, not an exact place. This might seem like a big deal, but it's really not. After all, you can still calculate probabilities. It's just that sometimes those probabilities will be very small. But that's okay because quantum mechanics is all about small things. Small things are inherently probabilistic. Just think about radioactive decay. We can't ever know exactly which atom will decay next, but we can calculate the probability that a given atom will decay within a certain time frame, and that's all we ever really need to know. So there you go. That wasn't so hard, was it? In just a few short minutes, you've gone from knowing nothing about quantum mechanics to being able to explain it to a small child. Of course, you probably didn't understand any of that, but that's okay. The point of this video is not to teach you everything about quantum mechanics. It's just to demystify it a little bit. Once you realize that quantum mechanics is just a different way of looking at the world, a world that's full of inherent uncertainty and randomness, then it's not so scary anymore. If you enjoyed this video, please like and subscribe. And as always, thanks for watching.